Hi students, and welcome to another episode in our C# Fundamentals course. This time we are going to repeat a bunch of concepts that we have learned in the last few weeks. We are going to talk about classes, about inheritance, about abstract classes, about overrides and things like that. I will show you only a few new topics today. We will mainly recap what we already learned and take a look at an additional sample. So let's get right into it and let's get started. Today, I would like to implement a zoo together with you, a bunch of animals, and yeah, we'll have some fun with them. So let's create an abstract base class. Abstract class animal. Take a second and think about how would you describe an abstract base class? What is an abstract base class? The correct answer would be that an abstract base class is a class that cannot be instantiated. You cannot create an instance of an abstract base class using the new keyword, but it's really just a base class which is used for inheritance. Let me show you what I mean. I cannot say var a equals new animal. That is not allowed in C# because an abstract base class is just for inheritance. Okay, so we have a base class for all the animals. Now let's create another class, and that is a derived class. And GitHub Copilot is spoilering, so let me disable GitHub Copilot here. So let's create a class cat, for instance, and this cat is an animal. Of course, cat is an animal. Now, please note that cat is no longer an abstract class. So that means that we can create instances of cats. Let me show you what I mean. I can say var c equals new cat. That works perfectly fine, while var a equals new animal didn't work because of the abstract keyword. I think by now you should have you have got the concept, okay? So just to have a little bit more than just two animals, let's add a third animal. I think dog is a good thing, so we have a little bit more to play with. And finally, we will add a bird, okay? A bird, which is also an animal. And now we have a nice little class hierarchy. Remember that those things are in diagrams are displayed as follows. You use rectangles for the classes. For instance, here we say that is our animal class. Then we have a second rectangle. That would be our cat class. And then we use a triangle. I'm not very good in drawing with the mouse, but I think you get the point. And then we use the line here, and that would be an inheritance relationship. So cat is derived from animal. And in the same way, we could now draw a rectangle for dog and bird, and they all would have this unfilled rectangle here pointing to the animal base class. Very good. So now let's implement some things here in our classes. What could be a content of an animal? For instance, we could have a public abstract string who am I, which is a read-only property. Please note that here we have the get keyword. By using this get keyword, this who am I becomes a property. And because this property only has a getter, it's a read-only property. You cannot set it. You can only read it. Abstract here means that every single animal, every inherited class from animal must provide an implementation of this property. Let me show you how this works, because currently we cannot compile our program because we get errors, obviously, because our descendant classes do not implement the abstract class. We can use the override keyword here, just select who am I, and we can simply here implement it for the cat. And in this case, I'm simply going to use the emoji here. See? So that is who am I? I'm a cat. I can copy this down to the dog and use a dog emoji, as you can see it here. And I can copy it down and use a bird emoji here. And with that, we have a compiling program again. Again, let me repeat it. This abstract property enforces that all the different descendant classes must implement this read-only property. And again, it's a read-only property because we only have a getter. So now it's time to practice for you. I will create a public abstract. This time I will say int legs. I want to have the number of legs here. So you see, my program does not compile anymore because I have an abstract read-only property in the base class animal. And now it's your turn to pause the video and implement the correct property getter for all the different descendant classes. Did you manage to solve it? Well, it's not that difficult, is it? We can say public override. Oh, sorry, it's much easier if you just write override and then just select it here, because then you can easily change it. We can say, okay, legs, we have 4 animals, 4 legs with a cat. We have 4 legs with a dog, and obviously we have 2 legs with a typical bird. Nice. And now we have a compiling program again. Nice. Next one. We already covered the abstract properties. Let's cover now abstract methods. Public abstract void make sound. Yep, I'm happy with that. Make sound should print on the screen a typical sound of that animal. Now this is an abstract method, not a property. It's important. It's a method. It's a method because we don't have a getter, but instead we have these parentheses that you see here. So that makes this abstract thingy here a method. So let's implement that one. Let's go down to the cat again, say override, space, and just select make sound, as you can see it here. And here we can easily implement that one. We can say console, write line, and that would be meow, something like this. Then we can take that one, put it to the dog, here it is, and that would be a woof. And then we have the same for the bird, and that would be a chirp, something like this. And now we have a compiling program again. Note that this abstract method here enforces that all our descendant classes must implement this method. And now I will teach you something new. Because what we can do is we can replace the abstract here, if we want, with a virtual. Now, if we change abstract to virtual, the base class can implement, if it wants to, it can implement a default implementation. It can, for instance, say console log. Console write line. Sorry, I'm in the wrong programming language here. No sound, for instance. See? So the base class has a default implementation. It comes with a default implementation. And now, if we have an animal that doesn't make any sound, the animal could, see it here, not implement the make sound method. That is possible. It is definitely possible that now the cat can decide to not implement its own version of make sound. So that is the big difference of abstract to virtual. Abstract means the base class is not providing a default implementation, and the inherited classes, the descendant classes, they must implement the method. With virtual, the base class can implement something, and the derived classes, they can override the logic. You see, if the descendant class overrides the implementation, it can decide to reuse the logic which is in the base class by saying base.makeSound. That would now call from here, from the cat, the implementation of the base class, which is animal. Of course, in this situation, it doesn't make sense, because if I just want to call base make sound, I can simply skip the complete override. But it was important for me that I show you how this works. Okay? So please remember the difference between virtual and abstract. I will now undo quite a bit of code, because I want to go back to the abstract version, because in this case it absolutely makes the most sense. Good. let's repeat. No, let's practice. Let's practice for another time. Let's say I say public abstract. What will I say? Bool likes. And then we say animal other. Yeah, that is a very good example. I can teach you quite a lot of things with this example here. You see, this method should return Boolean true if the concrete animal that we have, for instance a cat, likes another animal, for instance a dog. Let me show you how we can implement that, and then we'll discuss it, okay? So we say public override, this one, bool likes, with the animal other. Oops, yeah, it automatically completed everything and I wasn't expecting that. So now we are good. So now we have to think about who likes whom. And in our case, we want to return true if we like the other animal. And let's assume that the rule is cats only like cats. They don't like dogs, they don't like birds, maybe to eat, but yeah, in our sample they don't like birds. So we only have to return true if the other animal is a cat. The question is, how can we find out whether the other animal is a cat? And here I can teach you something new. What we can say is, we can say return other is cat. Or if you prefer the implementation with an if statement, if other is cat, something like this, return true, else return false. See that one? So this would be an implementation of this likes method. And the new thing that you just learned here is the keyword is. With the keyword is, we can check whether a given object is of a certain type. And in our case, other is an animal, and we don't know which animal other is. It might be a cat, it might be a dog, it might be a bird, but with the keyword is, we can find out whether it is a concrete type. And in our case, that's here the case. Now let's implement the likes method for dogs, and let's say dogs like everybody. They like cats, they like birds, they like other dogs. No, that would be too trivial. Let's say dogs like other dogs and birds, but they don't like cats. I know that's a little bit of a stereotype, but hey, it's okay for our purposes here. Let's say override, let's say like, and think about how this could look like. We could say return other is dog or bird. This is how you write it. It would also be possible to write or other is bird. That is possible, but it's simply too long. You can shorten that in modern versions of C# by just saying other is dog or bird. A powerful operator, this is operator, isn't it? Now it's your turn. Birds. Birds only like dogs. That is what we want to implement here. So pause the video and implement the business logic. Birds only like dogs. Pause the video and try to implement it on your own. I hope you managed to implement it. I will show you how you can do it. Likes. And here we can say return other is dog. And with that, you just learned how the is keyword works. Very nice. We already learned something new, and we have repeated a bunch of things which are super useful. Speaking of repetition, let's talk about another topic which we discussed, and I want to emphasize it here again. Can you remember the name of the super base class in C#, the class from which every other class derives? Correct, it's object. What we can say here is animal derives from object, and that is true, always true. You cannot prevent it. The master base class in C# is object. Every class is derived from object. And Visual Studio Code indicates that this object is not necessary to write by using a different color here. So you can simply drop that, and animal will still be derived from object. And that means that we can override all the virtual methods from object. For instance, toString. Can you remember what the purpose of toString was? The purpose of toString is to turn a given object into a string representation, which you can, for instance, print on the screen. What we could, for instance, do, we can say, I don't know, return something like this, and use here the whoami property with, and another property, legs. Who am I with legs, and then at the end we say, for instance, make sound, meow, or something like this. Oh, sorry, we cannot say make sound. Make sound returns void. That doesn't make sense. Let's keep it with this one, okay? So in this case, if we say toString, we get back, for instance, cat with 4 legs. That would be the idea here. And remember, toString is available here because animal derives from object. That is the important thing here. For those of you who really want to get into the details, I want to point out something very important here. Please think about this who am I here. Which property does this who am I relate to? Let me scroll down a little bit. Does this who am I property relate to the cat who am I? Or does it relate to the dog who am I? Or does it relate to the bird? Oh, that is the cat, that is the dog. Now, or does it relate to the bird who am I? So what should C# call here? Which property should it query? The answer is we don't know. It depends on the concrete type of the animal. Is it a cat? Then we have to call who am I from cat. Is this a dog? Then we have to call who am I from the dog. Is it a bird? Then we have to call who am I from the bird. And this dynamic mechanism has a name. It's called polymorphism. Please remember that name. It's really important. You will hear me talking about that a lot. Polymorphism, the concept of dynamic method invocation depending on the type at runtime, is super important when it comes to object-oriented programming. Whenever it's not clear which method, which property to call, when the method and the property depend on the concrete type, then we talk about polymorphism. To close today's session, let me demonstrate polymorphism with a closing sample, and then I will show you today's exercise, which you can work on yourself. So let me show you the final example here from this demo. Let's create a zoo, var zoo. This zoo should be an array of animal. See, an array of animal. And inside of this array of animal, we want to have a new cat. We want to have a new dog, and we want to have a new bird. We have a zoo consisting of 3 animals. I think that is fine. Now let's for each over these items. Var A like animal, var A, and here we want to have zoo. Var A like animal in zoo, and we can now call a.makeSound. This is polymorphism again. Why? Can you see it? See, this loop here loops over these animals. First cat, then dog, then bird. Now if you just take a look at this line and I ask you which make sound will be called, the one from cat, the one from dog, or the one from bird, your correct answer would be it depends. In the first iteration of the loop, we will have a cat. So therefore, we will call make sound of the cat. In the next iteration, we will have a dog. So make sound will come from the dog. And in the third iteration, we have a bird. So therefore, make sound will come from the bird. And that is exactly the concept of polymorphism. That is polymorphism. The target of the method is determined by the concrete type at runtime. It depends on what we have in this loop, and only then C# knows which method to call. Let's finish this method. For instance, we can say, we want to find out, for instance, if this concrete animal likes the other animals in the zoo. So what we can say is we can say for each var other in zoo, so we iterate again over all the animals, and then we can, for instance, say console write, and here we use a.whoami. Who am I? That's the first thing. Then we say console.write with a does. Then we say if not a.likes other. We say console write not. And finally, we say console write like. And finally, the other, who am I? The original element does, and then either not like the other or just like the other. And the important thing here is again polymorphism. This one, the method likes. Which method does it call? Cat.likes, dog.likes, or bird.likes? We don't know. Same is true for here, other.whoami. Other. Which whoami does it call? Cat, dog, or bird? We don't know. It depends on the concrete type at runtime. It depends on which loop iteration we currently am in. And that is polymorphism. So let me quickly try this program, but it really works. And then we are done with this example. .NET run. Let's see if I screwed up or if it works properly. It compiles, it runs, and I think it looks nearly perfect. I will simply say console write line here to make it beautiful. Let's run it again. That should be pretty quick. And wow, we have meow, we have woof, we have chirp, and then we see that the cat does like cats, the cat does not like a dog, and the cat does not like a bird. It works perfectly fine. Congratulations, you just learned a very important lesson in object-oriented programming, polymorphism. And do not forget, you also learned a new C# keyword, and that is the is keyword. With is, we can find out whether an instance of a class, a so-called object, is of a certain type. Very nice. We worked through this example, revisit the example again, play a little bit with the code, make sure you understand how these constructs work. And if you have any questions and you are in my class at the HTBLA Leonding, don't hesitate to just send me a message via Discord. And now it is time to practice. Of course, I have an exercise for you, and you can find this exercise in our GitHub repository here in this folder. It's called RPG, like role-playing game. The idea of this exercise is that you have to implement a single in-game fight logic of a role-playing game. If you're not familiar with role-playing games, just Google it, you will find it out. I will not read all the different rules here and so on. I just want to point out some important things. If you are already a quite experienced C# programmer, and if these concepts like classes and object and polymorphism and all these things are already quite familiar for you, you feel okay with these concepts, then I invite you to only take a look at this first page here, just the game rules. And then you come up with your own class design. Invent your own classes, invent your own class names, decide where you want to use a derived class, where you want to use polymorphism, where you want to use abstract or virtual. But I warn you, this is not a trivial task. Inventing something like that from scratch is really not that simple. So if you are still struggling a little bit with all these concepts of classes and methods and properties and so on, maybe you shouldn't try it. I mean, try it, but don't feel bad if it doesn't work out, okay? It's absolutely no problem. If all these concepts are completely new to you, if you are a beginner and you just heard for the first time about classes and object and polymorphism, then I have a detailed technical requirements document. It's very similar structured as our last exercises. Please revisit the videos in our course playlist if you maybe need a quick reminder of how to read these diagrams and so on. So here in this extended specification, I have laid out the hierarchy of classes and the methods and the properties in very much details. You see the different properties that you need, you see the abstract classes, you see the overrides, you have some sample implementations that you can use as an inspiration for implementing the other methods. And finally, I also added a bunch of test data, as you can see here, so to make it a little bit more interesting and also a little bit easier to approach this example. So if you are in my course, this is your homework. Try to implement this role-playing game. It is a very good exercise for the upcoming exam. If you are not in my course and just watching the video, hey, try it on your own. And if you have questions, don't hesitate to contact me via any kind of social media network where I am present. So thank you very much. Thank you for watching, and I hope you will have fun implementing this homework and this exercise. See you. Bye.